Let's now take a look at the stochastic volatility models. Essentially, for those type of models, you have an explicit stochastic process for the volatility term here, the V basically. And a typical process is that you have a stochastic process for the stock state variable of the stock price. And so this is a risk neutral process. Here you can use VS, but we use a square root of VS here. And then you can get an explicit stochastic process for the volatility itself. So here the volatility is modeled as a mean reverting process. And it's actually a CEV process because it has an alpha term here. And so every time when you have this process determines a particular realized V, and for that realized V, this process itself determines a realized new stock price. Okay, here the Wiener process for the stock evolution and the volatility evolution are not correlated. Now, if that is the case, if the process of the volatility of the random innovation for V is not correlated with the stock process, then Hall and White showed that the simple options can actually have a relatively simple form of an integral. And so that gives a relation between the Black-Scholes price and what the actual, this should be the observed price or the model price under the stochastic volatility model. And if you treat that the actual market observed price should be under this model, then you would have used a C here being the observed market price. Now, with this, you can then try to back out some of the parameters that you may require for the process to work for this underlying process here. Some of them you may have to go through a statistical estimation to get the parameters. Some of them you can actually determine based on this condition here. It's interesting to know that in this case, this condition is actually not dependent on the actual process followed by V. So you can actually specify a different process here. This integral will still work. This form will still work, provided that your the random process, the DZV here is uncorrelated to DZS. So that's all the condition you need. Okay, so with that, under the stochastic volatility model, it produced a pattern of implied volatilities that is typically observed in the currency option market. So you get this volatility smile here.